Good morning.
Good morning or afternoon, wherever you are,
Or evening, I suppose.
or evening. Yeah, true.
I'm back at home, which is
Finally, man.
well, it's good, but it's also
Not good.
it's 92 degrees and it's 10 a.m.
Pros and cons.
It's absolutely miserable outside, so my kids can't go outside because trying to put sunscreen on a 4-year-old is sort of like trying to put sunscreen on a very large flappy fish. And and she wants nothing to do with it. But I also don't want a bright red, painful sunburn all over my
Yeah, you
4-year-old.
just need to be
So,
careful these days.
but it is nice to be home, back in back in the land of good internet at least. So
Yeah, and good equipment.
yeah,
You're not off just your laptop like the last times.
yeah, that's true. I'm back on a real machine. So maybe it won't take half of my PC's resources just to do the stream on top of everything else that we're doing. So.
Exactly. And what are we doing today, man? What are we doing
Um,
today?
So last week we did Blazor with um, Blazor server side with Azure AD, right? Which was cool because we could get signed in really pretty similarly to how we did before, and we talked to the graph. So we got a token.
Yep.
We went and talked to the graph. We did our user read, our mail read, and we showed the surprisingly inoffensive emails in my inbox.
It was just spam, which is nice.
But the biggest pain in all that was that we were using an in-memory token cache.
Correct.
And because we were using an in-memory token cache, every time we restarted the app,
Yeah.
we would have to sign out and sign back in because our cache wasn't persisted really anywhere, right?
Correct. Yep.
So we figured it'd be good to do sort of a proper persisted cache somewhere.
Mm-hmm.
So,
Absolutely.
so what should we use locally? Should we start with something like distributed cache and like use
Well,
SQL, like local DB, or
I think first of all, it would be nice if we open the docs and just show that the new Microsoft.dent.web has made it super easy to implement a distributed cache or a local cache. And the fact that everything is deriving from I distributed cache means that you can also implement your own customized one. So for the newer, latest Microsoft.dent.web, it becomes much easier to do it.
okay?
But so I think today, I think yesterday we were discussing something about Cosmos DB. So I was wondering if we should take a stab at that and use a Cosmos DB as distributed, or we can go with the one which is out of the box, and that's the SQL. You can use SQL or Redis. Are the two options, if I remember correctly. There's a Stack Exchange Redis as well. So there are a few options. If you go to the docs in GitHub, you should be able to find the appropriate documentation.
Oh, that's right, because identity.web has a wiki,
Has a wiki indeed.
and that wiki has a whole lot of great information, right?
Yeah, so on the right hand side, there you go, token cache serialization.
In fact, let's put this link in the chat
Absolutely.
for anyone who is for anyone who's following along. So the wiki actually has some great sort of extra details about
Hmm.
the identity.web library. Makes it a little bit easier to get started. And in fact, we used this last week when we were setting up our new app. So
Exactly.
let's see. So there's a big thing about token cache serialization. One of the things we talked about last week was how you use the token cache in
Hmm.
identity.web and an MSAL, really not identity.web, but an MSAL. And
Yep.
the MSAL token cache, you can completely build one from scratch if you want, but instead, you could also just hook into some provided events that we give you, right?
Exactly.
So
Yep.
instead of having to deal with the entirety of a cache, so how do you encrypt the data? How are you going to decrypt it? What are you going to do for managing the data? Like instead of having to deal with that on your own, we give you some hooks, an after access and a before access. And
Mhm.
those two hooks are what you use to either write the bytes or read the bytes and hand it back to MSAL. And once MSAL
Correct.
has the bytes, it handles everything else around serializing or deserializing that token cache. So if you don't have a reason to build your own from scratch, there's really no reason to, right? I
Yeah,
mean,
you shouldn't, to be honest.
yeah, unless you have a really particular way that you want to do the caching, or if you don't like the structures that have been given for doing the caching, there's really not a whole lot of reason to do it on your own. Because in most cases, at least, the majority of the reason why you use a cache is to persist these things somewhere else, right? Is to persist your tokens somewhere else.
Yes.
And usually persist them in some sort of durable storage. So if your only concern is durability across reboot or across restarts, or if you're working in a farm and you've got multiple nodes, and of course in cloud, literally 0 of your nodes are ever guaranteed to last longer than a few requests, then you got to have some sort of durable place to keep your tokens, right? You can't keep them there forever. That's pretty much. If you don't have a reason, you don't have a reason.
It does sound like your line. I mean,
or maybe a John Madden one. You know, if he gets all the way down there to the end zone, it'll be a touchdown, right?
JP has a lot of wisdom in him, so follow along for.
I don't know if wisdom's necessarily the right word. It might just be arbitrary information.
I could put air quotes around wisdom. How would that?
But there's a whole lot of it. There's a whole lot of arbitrary information in here somewhere.
True.
Right,
So if you scroll down a little bit on the documentation, you'll see that we show you how to implement it, and then what's even better is that we give you out-of-the-box experiences for creating these token caches, especially for distributed ones.
Yeah, so we've got 3 primarily. The in-memory ones, which are the ones that we were using last week. See here on 41. Yep. We've got the session token. So if you're dealing with, or if you're using session, we can use this to persist your token cache. Or if you've configured a distributed cache for one reason, for one reason or the other, then you can use an iDistributed cache, which is part of ASP.NET Core. So what's cool about that is instead of having to manipulate the cache and even hook into the events that we give you in MSAL, Identity.Web's going to do it for you, right?
Exactly.
And in fact, this morning, there was an issue that had been open for a few months, specifically around manipulating the token cache and how you access it. And it turns out it's been fixed and been closed. So
sweet. There you go.
I just got that notification like an hour ago, so that's awesome. So I guess to start, what did we? Do you want to go Cosmos? Should we do Cosmos to start?
Yeah, because this is my curiosity. As long as the Cosmos DB iDistributed cache is implementing the interface, which it does, then all we would have to do is technically just plug it in, and should be plug and play. We can test it. If it doesn't work, then we can go back to SQL or Redis. But I would love to see us being so plug and play that we don't have to worry about anything. And right now, I see you're downloading the emulator because we don't want to spin up a Cosmos DB on Azure and spend money. We want to just test it locally and see how it works, because that's fantastic, right? Being able to run Cosmos locally, it's brilliant, and the emulator does that for you. So we can test it locally, see if that works, and then if we're happy with it, we can push it to Azure.
Yeah, that's what I think. I figure we might as well we'll just develop it locally, because if it doesn't work, then that means I have to go remember to delete a resource. And if
that's a perfect segue into the Asman software that we were discussing earlier on, right?
Yeah, so we'll have to do a stream on that. So
a segment. Yes.
A while ago. Oh, I can't even get to my emulator. I wonder why.
Did you run it? Is it running?
I did. Open Data Explorer request too long. I'm guessing there's a bunch of extra header data in here. That's the only thing I could really.
Do you have any blockers or any odd stuff that could block it from working?
I mean, I guess I'll try it in a different window.
Wow.
That's a little weird, but okay. There we go.
That's disheartening.
All
Oh,
right.
or maybe it took time to spin up all the resources.
Well, who knows? This is like Windows Beta and Edge Canary and who knows what Visual Studio Preview. Who knows what
Living
current?
dangerously.
Yeah, who
Living
knows?
dangerously, my friend.
Who knows what the state of this is? So,
Yes.
so this is our emulator, right? So this is our Cosmos DB emulator, and it's pretty similar to what you pretty similar to what you get in the portal, right? So a lot of the exploring or the explorer views are kind of the same. Create a new container, create a new database. But for us, for right now, I think primarily all we're really going to need is our connection string,
Yeah.
and at least historically, these secrets were all identical. So every emulator had the same secret. I don't know if that's
You
still the case
did?
now.
Oh, wow.
Well, but I mean, it was running locally, right? So yeah, so here it is. So if you search for that secret, you'll find all sorts of pieces in here. The side effect to that, however, is GitHub will give you a bunch of alerts and warnings saying,
I'm
checked
curious
the
to what
secret.
happens if you go into GitHub and search for that string right now.
I don't know if we're ready for this. It'll,
You do know that if you search for RSA key or begin key or begin secret, then you find thousands upon thousands of private and public keys in GitHub.
I know it's not a good thing by any stretch. Here, let's go to GitHub in
Nope.
a window I'm signed into, and let's search for that. Search for that key. I have a suspicion we're going to find quite a few. Yeah,
How many? 2,000.
over
There you go.
2,000
That's
bits
not
of
too
code.
bad.
It's even in 3 wikis, but that's okay because it's
Could be
local.
one of our wikis though.
Well, I could see the advantage of having
Consistent key.
consistent keys for a local emulator, because if you're running tests or in some sort of integration test and you want to run it somewhere, having to do an installation on like a test runner or on a load testing box or something on some sort of an agent and then deriving the key from that, I could see that being a huge pain.
That's a good point.
So I think here it certainly makes it a little bit easier. So
Okay.
all right. So let's go back to our docs for the token caches. So all we have to do to identity.web is, instead of using an in-memory cache, we're going to use a distributed token cache. So we're going to do add,
Love it. Just a one-liner, man. That's it.
add
That's all you need.
distributed token cache is cool. And now we have to go configure a cache, right? We got to go configure our distributed cache. So
Correct.
let's go find a Cosmos DB provider for iDistributed cache. Cosmos DB. And I like Cosmos a lot. Like, it's gotten a lot cheaper too, which makes it a lot easier for dev. I think you can go get one now. Like, in fact, there might even be a free tier now, but
There is a free tier. Let me find it.
yeah, historically there was even the cheapest one was only 18 or 19 bucks. Which if you're fortunate enough to be working in a place where you get MSDN, it makes it, that's well within your allotment. So, but even if you're not, 19 bucks for a pretty fast, globally distributed database isn't too bad.
True.
So let's.
I mean, Cosmos DB comes with some amazing features, and even if you have to go to a paid version eventually because your application is grown, then it definitely gives you many, many things that you don't have to worry about if you were using SQL or something else where you have to do global distribution of your data and what have you.
Yeah.
So I love it. Did you find the right package?
Well, it looks like this package is still pre-release, so it's 1.0.0 preview 3.
Living dangerously.
Well, so
I mean, Identity Web is still preview as well, so we have to say that. But we are heading towards a GA release very, very soon. So people should be excited about that, as we are. Somebody said there is a free tier, very popular with live coders for I'm not myself said. There's a free tier for Cosmos DB, and it's very popular with live coders. That's good to
Oh, very
know.
cool. Very cool. Good.
Yeah.
Good to know. So this is the extensions caching Cosmos library. We put a link to it, link to the
Mm-hmm.
repo out here in the chat, so we've got it available. So we've got our caching library available. Let's see, what is our use for this? So we can use an existing Cosmos client or a Cosmos builder, but
Ooh,
it is largely it's largely fairly straightforward. There's really not a whole lot here. It doesn't look like, which is great because it means that we make a couple config changes and
correct. So you need 4 lines, 5 lines of code to configure and add your Cosmos DB cache, and then you just and I think it automatically gets picked up by ident.web. You don't have to explicitly go and say something about Cosmos DB. It will pick up the distributed cache.
yeah. I think this is when you say something like trust the process, right?
Yes,
But that's the
that's
.NET
the pipeline.
developer. That's what we've done in .NET for a long time. Um, is you do the things that you're told to do, and you're like, okay, I think this is going to work. I hope this is going to work. And
Well,
then,
I like trusting the team that has built these things to do it right. So all I have to do is just use it.
yeah, that's true. Let's hope that all we have to do is just use it.
Just need the Cosmos cache container
Yep.
string somewhere.
Yep. And I guess we need to create create if none exists is set to true. I'm assuming that this is going to create a database in a container. Although,
Exactly.
let's see, this is saying it will check for the container existence. So I think we probably have to use we probably have to, if we want to change the throughput, we'll have to do that manually or create it up front, right? So let's go add, we've got a new configuration section we need. Oops. And we have what, a few different settings here. So we've got Cosmos Cache Container. In fact, these are not even,
It's not a section, right? It's just add the root.
let's create a section.
Oh, look at you.
Well, we've got other things in here, so
Should we do it at a secret? Like, should we put the key in a secret rather than put it here for best practice?
I suppose we could, although it is a well-known secret. And if we were to
That's a good point. You're right.
if we were to deploy this to Azure, I don't think we would, we wouldn't use this anyway. We'd use something like app service config or Azure
Key vault
configuration. Yeah.
or
Key vault. Yeah. So we have,
ring on the key vault.
so let's see, these are Cosmos Cache container name, Cosmos Cache database name, and Cosmos Cache connection string. Okay. We get these in our settings here. And then let's go grab our connection string out of the emulator. So I guess, I don't know if you can call it a well-known secret. That seems like somewhat of an oxymoron, but let's see. We'll just call this token cache, and we'll call this the
Blazor database or something because we're using on the Blazor cache.
not very descriptive, I guess, but
Not
okay.
as good as Asman. That topped the day for me.
Well, we need to schedule it up because there's a bunch of service principal work that goes into that. So, okay. So now, in theory, of course, I think we've done everything we need to, right? So we've configured our Cosmos builder.
Yes.
Let's see. The provider stores state in a container within a database. Both parameters are required within the options initialization. Create if not exist, we'll make sure to create a container if it doesn't exist with an optimized configuration for key value storage. That feels a little opaque, so I'm kind of curious what that means. Container throughput can be used to specify a throughput on the container. I mean, I think to start, 400 RU, the 400, the arbitrary unit for measuring Cosmos performance, right, is 400 RU is probably plenty. I don't know what their default is, so we should dig into that a little bit and see. So what's nice about Cosmos though is, or maybe not, it's provisioned throughput, right? So when you use this, you're saying, please carve me out this dedicated chunk of throughput, 400 RU or 1,000 request units or whatever, and it gets provisioned. But the downside to that is you're paying for it. You're paying for the fact that it's been provisioned regardless of whether or not you're using it, right? So we had blob storage years ago. It's like the standard blob storage, and standard blob storage was cool because you could allocate a 2 terabyte file, and if you wrote 20K to it, you'd pay for the 20K.
Yeah.
And then we got premium storage, which was all SSD backed, but it was pay on provision, not pay on use. And Cosmos is the same way. So Cosmos is a pay on use type of pre-provisioned service. So when you do a provisioning, the meter starts to turn immediately, which is something to keep in mind when you're building these things out.
Yep.
I'm glad you got that mechanical keyboard because it really keeps me. It makes me feel like I'm sitting right next to you.
And I went for the soft switches, right? I should have gone for the hard ones. It should sound like a typewriter. It just gives you this satisfaction when you actually commit a letter to the keyboard. I don't know. I don't know how everybody else feels about mechanical keyboards, but this is my first one, and I love it.
So I remember at the library I went to as a kid, which was admittedly 25, 30 years ago, they had IBM. They had IBM machines that had these green screen like phosphor monitors on it. But
yes.
The keyboards they had, I mean, you had to have significant finger strength to get those keys down. So like if you
like a proper typewriter, it builds character.
Yeah, it does build characters. Interestingly enough, it's exactly what it did. It built a whole list of them.
Look at that, an accidental pun. Isn't this amazing?
Oh my God, it's too early. And we're going to scare everybody off. Nobody's ever going to come back. But
that's a 4-shot espresso iced coffee this morning, so you can see why I'm so wired up, right?
But the thing I remember about that keyboard wasn't how loud it was, right? Because you could always tell when anybody in the library was looking for a book. It was the weight of the keyboard itself. Like, I don't know if the terminal was in the keyboard, like for connecting back to whatever the back end was, which I guess was probably some kind of a mainframe. But the keyboard itself, I mean, that thing probably weighed 10 or 12 pounds. And, but it was super satisfying to type on, even if you didn't have anything worth typing. And you would type, and then your characters would show up on the screen about 8 minutes later. So, good times. But anyway, okay. So we've got our cache configured, we think, and we have MSAL and identity.web configured to use our distributed token caches. So, in theory, when we run this, we should have a token cache get created in Cosmos, and MSAL should start using it, right? So, I guess the only thing left to do
is run it.
Is run it and see what we get.
Tan, fingers crossed. It's gonna be awesome. I'm telling you, it's gonna work out of the box.
Hopefully, build times are a little faster on this machine than they were last week. Because last week was pretty brutal. There were certainly days where I was like, "Oh God, it's so slow. It's killing me."
You are now making a very good case for me to build my own box. The desktop after probably over 15 years of not having a desktop. Oh, look at that.
Okay.
No, the pipeline has already worked, man, because if there was an issue, it would have blown up by now. Let's see what happens.
Well, the real key, the real test will be after I accept this and we get redirected over back to the app, and the app tries to swap the authorization code for an access token. That'll be the real test to see what's happened. So and when we do that, we'll go check in the emulator and see what's been created. Okay, so we've accepted it. Setting consent, which we had to set consent again this time because I, in my haste, deleted the app registration last week and realized that at about 7 minutes before. We started. So, okay, so we've got our apps. That's good.
Yeah.
let's go fetch data. These are our graph calls. Cool. So it looks like we did get a token, and it looks like that token was stored somewhere. So here are my latest emails. You can tell this is an
Recent ones as well. Look, you got your this morning's email about Identity Protection Weekly Digest.
Yeah, so you can. So this is the same experience that literally anyone who's an administrator of an Azure AD tenant somewhere has to deal with every week.
Yeah.
I feel like I get the weekly PIM digest about 4 times a week. I'm not entirely sure how that happens, but it does.
We want to make sure you get it, not just once.
And my old doctor still thinks that I'm either pre-diabetic or a heart disease risk. That's super fun, but good for me. I haven't seen him in like 10 years, so he doesn't even know. And it looks like looks like my bicycle store is selling gravel.
Wow.
But I'm such a noob when it comes to riding a bicycle that I don't know why you would need gravel if you ride a bike. Okay.
Yeah, please tell us, why do we need gravel for our bike?
Okay. So let's go look at our Cosmos emulator, and let's see what, if anything, actually ended up in here. Okay.
Yeah.
All right. So here's our Explorer. Oh. Request is being made with a forbidden encryption in transit protocol or cipher. Okay.
You've broken your emulator today. That's crazy.
Yeah, that's pretty wild. I can't say I've ever seen. So why on earth is this thing using like TLS1 or something? Like, why would I not be able to connect to an emulator? I wonder if the emulator is just like, maybe it's old or something. But I could connect to the emulator itself. I just can't make this HTTPS call.
I think you can use Storage Explorer to hit your Cosmos, right?
This is pretty weird. Yeah, you can use Storage Explorer. Let's open Storage Explorer, or maybe I'll just open. I could just open something like Firefox too, and see if that.
No, I don't think it's the. I don't think it's your browser. I think it's something with the underlying emulator engine that's not working well.
You think so?
Yeah.
Well,
I mean, do you have Firefox or Chrome to test the case?
I have Firefox, so let's try Firefox.
Okay.
Oh no, same thing.
See?
Request is being made with a forbidden encryption in transit protocol or cipher. Well, it almost kind of feels like, I'll zoom in a little bit here on Storage Explorer. It almost feels like it's, because, of course, TLS has been changing a lot. It almost, and especially minimum versions, right? Everybody's been pushing to get to TLS 1.2 only, right, as the minimum. So you can't use 1.0 or 1.1, which makes me wonder if perhaps the emulator is still using an older, older protocol. So, okay, but we can connect to it in Storage Explorer for now. But yeah, you're right. We should probably raise that is a bug. So here we've got our emulator. We're connected up in Storage Explorer, and here's our Blazor cache. Here's our token cache collection. Let's look at the documents we've got in here. So we've got one here. It's got an ID. Now, if you remember from last week, that ID probably looks kind of familiar, right? So I know from having used this tenant for a very long time that 98A34, this is my test tenant. So this is my tenant ID. And I'm pretty sure last week we confirmed that this is my object ID. Does that sound about right? And then the content, of course, is what looks to be base64 encoded data, which is pretty much unusable, directly here in the database. But that's fine because, again, we don't really care about the actual caching implementation itself. We only care about the persistence. But what was cool about this is we didn't even deal with the persistence. Like, it was just there and it just worked, right? That's awesome. So we've got this token cache. So in theory, I should be able to... That's true, yep. Yeah, no, this is awesome. Like we literally copied and pasted 2 bits of code, and we now have a working persistent cache. Now, whether or not we can get the data back out and whatever, we'll test that here in a second. But by adding distributed token caches to Microsoft.identity.web, that is going to configure MSAL, which again, you don't even deal with MSAL directly in here. That's going to configure MSAL so that MSAL will have a durable cache behind it. You don't even have to worry about how do I set up a cache or what do I do? Do I have to have a separate cache just for my identity system? If you've configured a cache in ASP.NET Core, it just works, right? So this is super cool. I haven't used this yet myself, so the fact that we could get this up and going in 2 minutes was pretty cool, I think. All right, that's it. We'll see everybody. You know. Oh boy. So I'm gonna open up an app that I wrote a little while back. Now, before we go to there though, so I closed the process, right? So the process died, which meant last week our in-memory cache was gone, which meant that we couldn't go and get data from the graph again because we didn't have a token in our cache that we could go back and use. So now let's see if our token cache gets rehydrated correctly, and it does. So we went back to the graph after having closed the process, meaning our token cache is working correctly because our token cache is pulling in, our token cache is getting pulled from Cosmos, which of course is persistent on my local machine because we're using the emulator, which means now we've got a token cache that persists across nodes or persists across worker process recycling, or if your app has a catastrophic failure, at any point, now we've got a durable cache that we can use for our tokens, which is super cool. So, oh, I wonder what happened. Oh, I wonder if was I having an issue, perhaps? Well, you're coming through Skype. Oh, okay. I hope you're not muted anymore. Did you hit the mute button? Uh-oh. All right, hang on. Well, tell you what. Do you want to hang up and call me back on Skype? Okay. I don't know what happened. It's kind of weird. Yeah, apparently so. Okay. How would I rate the quality of that call? Well, it was good for a while. Okay. Let me make sure I get you.
And I'm back.
Hopefully, sure I get you hooked back in here. Looks like you're back in stream, which is good. So let's see if we get your audio.
Let's hope that the audio is working now.
Okay. Yeah, it's pretty weird.
Apparently, people still want to hear my comments, which is good. Encouraging.
Maybe it's some sort of maybe it's like a noise canceling algorithm because of your keyboard.
Oh, okay.
Duct tape and twine is probably the best. That's a very generous way to describe it.
And they can hear me now, which is great. Hey, thanks for letting us know. Yeah. You missed all my my snarky comments 5 minutes ago, but thank you for letting us know.
So, okay, cool. I'm glad you're back. So let's go look at doing token caching the hard way or the manual way without using identity.web, right? So this is if you're using MSAL directly.
Yep.
Then and you want to persist your token caches somewhere else. You sort of have to do it on your own. So
this is back in the either .NET Core pre 3.1 days where you didn't have ident.web or any classic .NET, right?
Well, this is anything that can use MSAL.
Great.
So, and I know you've been working on a matrix of what supported where.
Mm-hmm.
But as long as you can use MSAL, then you can use what we're gonna take a look at here. So,
Sweet.
we'll get this solution loaded up here.
Should we also cover what that scenario was for you when you started building it and what you were trying to do? Because I think just giving a little bit of a background of what you were trying to achieve and why you needed the cast in such a way may make sense for people or inspire
Sure.
some people to build something similar, right?
Yep. So, if you remember, a few months ago, not entirely sure when this was. It was a while ago though, maybe 4, 5, 6 months ago.
Mm-hmm.
There was presence information published into the graph from Teams, so people could see uh, your
Availability.
yeah
Yeah.
your availability. They could see if you were busy on a call in a meeting, whatever. And if anybody remembers, years and years ago, way before Teams, we had things like LCS and OCS and Link and all the different renamed executables. All of those also had hooks in them where you could do different things and pull different pieces of data, but they all sort of
Yep.
relied on that server, So the the side effect was when we moved to Teams, there really wasn't a good way to get presence data. Which, if you had one of those Imbrava lights, it
Mm-hmm.
was like a little light that you could put on your cube to say, "Hey, this is our this person's busy, so don't come and bother them because they're on the phone or because of whatever."
Yep.
Those kind of didn't work with Teams. I mean, I think there may have been some super convoluted way you could run some software that use the Skype for Business bridge or something to figure out your status and availability and then post it. But it wasn't very useful and it wasn't very reliable. And so presence information then started getting published to Teams. And at the time, there was no mechanism for getting a push of somebody's presence. So if you wanted to read somebody's presence, you literally had to go do that over and over and over again. Go pull the graph and say, "Hey, what's this user's presence? Hey, what's this user's presence? Hey, what's this user's presence?" And then do something with it, right? And so for me, since I'm working at home now and I have 3 little kids under 6 and a wife, I wanted to let them know when I was on the phone. So they knew maybe that's not the best time to come and pound on the door and try to get in Dad's office, right? Although I think it had the opposite effect because then they would come and beat on the door and say, "Dad, the lights change color." So it kind of, I don't know if it necessarily had the correct
The
effect,
desired effect. Yeah.
that's cool. I mean, it was fine. They had a good time, and I kind of made it clear like, "Hey, we can't do this." So
Mm-hmm.
my goal was to build a replacement for the Imbrava Link B-Link light
Okay.
and use Philips Hue or whatever, right? You could use whatever you want, but
Yep.
I wanted to use Philips Hue because I happen to have a few of them. But I didn't want to pull the graph every 5 seconds from something running locally, right?
Yes. Yeah.
I didn't want to run that same polar from 2 different places because I also, before coronavirus, I was still going into the office occasionally. And
Mm-hmm.
at the office, I had a real problem with people driving by. And so if I was on the phone, people would come by and they'd kind of sit around like, "Oh, you on the phone?" It's like, "Well, I've got a giant headset on with a big microphone in front of me, so it's possible."
Talking to myself, obviously.
So I had one of these tall IKEA lamps, right? It was like 4 or 5 feet tall. Then it had 3 bulbs in it, and I thought, "Oh, this would be perfect. I should use this. That way, I'll put it right at the edge of my desk, and if anybody comes by within 20 feet, they'll be like, 'Oh, okay, yes, on the phone, whatever.'" So what I ended up deciding to do was to build a cloud polar and functions, right? So the cloud polar would go and check presence from the graph, and then when there was a change, it would push that down to subscribers using Service Bus, right?
Right.
So that way I could have local agents that ran here, one that ran at the office, and so that whenever my status would change, instead of each one of those individual pollers polling it, we had one poller, and then could subscribe to many, right? So many subscribers could come and figure that out. So the side effect of that was that we now need a graph token for a user, right? Because getting permission to read every one of your organization's presence, at least for me, was not going to happen. Like, Microsoft is not going to let me read the presence data of the entire org. So instead, I had to use a delegated permission. I had to use a permission that was mine, or that was specific to me. And so because of that, I had to figure out a way to sign a user in, cache them, and then use their refresh token to go and get subsequent access tokens, right?
Sweet. Right. Love it.
So that was...
And you did all that in functions.
I did it all in functions. So, in fact, I've got a diagram. Let me pull it up here. And also, yeah, we should do this on the Thursday community call.
Yep.
To review I am not myself's code, because I remember getting that right before I left for vacation, and so we should take a look at it and maybe talk about it on Thursday.
Yeah, we will.
Yeah, so let's do that.
We'll have some answers for you, sir.
Yeah, let's do that Thursday on our community call. So there's a blog post about this. This was back in March, so it was sort of right before coronavirus.
Yeah.
And this is one of those Imbrava B-Link lights, right? So this is what we used to have, right? This little tiny light that sat on your desk. And I've got a diagram here. In fact, here's the light that I put in my cube at work, because it was getting sort of out of hand, right? So this giant, 4 foot tall lamp that would change colors. So this image here, this is sort of the key of what I had to build. So we have a timer function, and that timer function is going to go and query the graph for my current presence for each user who needs to do it.
Well, first it needs to get the token before it accesses the graph, right?
It does, which is getting him gets him out of a table to get the refresh token. Then it goes down to Azure AD with the refresh token to get an access token. And if you're not familiar with refresh tokens, a refresh token is sort of like a super long-lived token to get tokens, right? So a refresh token on its own doesn't do a whole lot, except it allows you to present it back to an identity system and say, hey, I need a new token, a new access token that I can use against a service. So if you just sent a refresh token to a service, to like the graph is going to say, well, I have no idea what this is. Mm-hmm. Don't call this number again, sort of thing, right? Like, don't try to send me this again. So instead, we present the refresh token to Azure AD in our case, and Azure AD takes that refresh token and will issue us a new access token that's valid for 60 minutes, right? That we can go and use against the graph. This is the same mechanism that things like your cell phone, like the Outlook app on your phone, or Teams, or Twitter, or whatever. That's the same mechanism that they use for ongoing access. So when I sign into an app on my phone, for example, when I sign into an app, I get an access token and a refresh token if it's configured that way.
There's a good question. Does Azure AD do refresh token rotation?
So if by rotation you mean you get a new one every time you use one, yes. So every time you send in a refresh token, you'll get both an access token and a refresh token back. And then that new refresh token is the one that needs to be stored. There are also some other considerations with refresh tokens. There are certain conditions where a user's refresh tokens will be invalidated, either through a manual invalidation, like an administrator can go and revoke your refresh tokens. So if your account got compromised, or if something's happened, you've left the company, or something, you changed roles or something, and they want to revoke them, an administrator can manually revoke them. But also on things like password changes, password resets, disabled accounts, there are a few different things which we've got a doc that outlines all the different conditions. In those cases, your refresh tokens will be invalidated, which means the next time you present this to Azure to present this refresh token Azure Azure AD just will reject it and not give you a new one.
Right.
So, so we do rotate in the sense that we'll send you a new one every time you use one, and the new one is the one that you're going to want to store because that's the one that gets persisted. If you're using MSAL in any of the languages, Python or any of the server-side languages, Python, Java, .NET, we handle that for you. So whatever ends up in the cache ends up being your new refresh token, but you don't have to do that work yourself if you're using one of the MSAL libraries.
Exactly.
So the timer function goes and gets a new access token using that refresh token, and then goes and gets the graph data. If the graph data is different, if the presence data is different from the last time, then it publishes it to a topic. And the subscribers who are subscribed to that topic in Service Bus receive it, and then they go do their thing, which in my case...
I have a question. Why did you choose Service Bus over Event Grid?
Because I had specific topics for my subscribers, for my presence data, and I wanted to control when the messages were... I wanted to get a little bit more control over the life cycle of the message, so when the message would come in, I would go and do work, and if I couldn't finish the work, then I would not complete the message.
Ah, interesting.
So that's one of the really nice things about queuing in general, and at least in the primary message queues that we have in Service Bus and in Azure Storage queues, is the way that you use them, and a lot of it depends on your app, a lot of it depends on your code, is try to do the work before you've deleted the message, right? So that way we know the work that needs to be done on that message has been done before the message is deleted. Because if you're halfway through doing the work and your processor dies, right? Like something dies, some other processor can come and pick it up, right? Because eventually that message will reappear back on the queue. And so the next worker that comes in to look is going to say, oh, well, I've got this message, right?
Yes.
The other things to consider, though, are if you start doing the work, say, halfway through, and it stops working or your processor dies, like, what does that mean? Like, what's next? Does that mean you have to go and can you just revert the changes you made? If you process the same message 1 time, 10 times, 20 times, does it have, side effects, right? And do you have to do like compensating transactions to invalidate half of the work being done, right? So if I do if I'm doing a credit card transaction, for example, right? If I fail halfway through, but I know I got part of the work done, then that means I most likely have to go and do a compensating transaction as opposed to trying to invalidate the transaction that already happened, right? Or even in the simple case of I started turning off lights in my house, right? But I only got halfway over. Does that mean I need to understand the state and try to revert the state, or do I just do the same operation all over again? It's the whole thing around item potency and what can we do in a transaction multiple times without having a side effect. And when you're working in these types of queues, a system that understands that and can process the same message 10 times without side effects makes your life as a developer much, much easier, because your semantics of how you interact with that queue become, I check the queue, I might peek at a message to see what the data is, I go start to work, and when I know I'm finished with the work, we complete it, and we've effectively deleted the message from the queue, right? So I had a function that was running locally in a container on a Raspberry Pi that would talk to the Philips Hue bridge and say, "Hey, set this light group to a specific color, depending on what my presence activity was." And so this was the one at the office, and then this was the one in my office down here in my basement where I am. So you notice like these 2 lights back here in the back are green, because I was green at that point. So, and I've turned it off in here now because I want to have decent lighting. But most of the work from the topic downstream is fairly straightforward. Make an HTTP call, the HTTP call goes out, and it talks to something to say, hey, go do some data on this, or go do some activity on this endpoint, which is fine. The hardest part of all this, by a significant margin, was figuring out how do I do token caching the correct way, right?
Yes. It's a challenge.
Right. Technically, this is a web app. Technically, this is what we'd call a confidential client because the client itself, so in our case, the function is capable of storing a secret securely. So we have public clients, which are things like mobile apps, and we have public clients that are mobile apps and JavaScript apps that run in the browser and apps that like run on your desktop. And then we have confidential apps, and confidential apps can store secrets securely. Hopefully people don't have access to your web server, for example, to get your secrets, right? Or you don't broadcast your secrets on the internet or check them into your source control. But public clients don't have that benefit. They don't have that luxury because they are on a device that you really can't trust, right? Anybody can go find an APK for an Android app, and there are tons of disassemblers out there. Hell, you could run a disassembler in the browser. There are services out there. You upload an APK and you get code back, right?
Yeah.
So it's very difficult to store a secret locally on a device that you don't want your consumer to find, right?
Yes. I want to slightly interject here because while we're talking about the token caching, there's something that we were discussing yesterday with regards to the presence, which is the fact that we have webhooks that support the getting presence via webhook. So you don't need such an elaborate solution that JP has put here, although it is covering certain scenarios. But the fact that we have the team's presence now as a webhook means that it becomes a lot easier to register for those events and then respond via a function or whatever else code you decide to use, which I think a couple of months ago when you implemented this one, or 4 months ago, this didn't exist. It wasn't supported.
That's true. So we did not have webhooks yet for for presence. So the graph has certain objects that have webhooks available for things like change tracking. So certain objects in the graph, like the user object, I think event objects, there are a couple other objects have webhook support. So when one of those changes, your endpoint will just get a typical sort of webhook call. So you'll get an HTTP ping with some identifying data, some identifiers, metadata really, about the event that occurred, and then you go to the graph and go see, okay, cool, like what are the changes that have happened, and you go get the latest change.
Exactly.
Which pretty much invalidates 75% of this, right? Because we no longer need a queue. We no longer need we really can run local functions now, unless you want to decentralize your presence to a single topic and then have your subscribers go off your topic. I was doing a little bit of data enrichment, so I wanted to have a single topic. But this hard part, if you want to call it that, of figuring out the token cache and figuring out what you were going to do to get those tokens on a reliable basis or on a regular basis, a lot of that's been invalidated by the fact that webhooks are available for presence data now. So you can subscribe to a webhook to get that data, and makes it much easier to do this without having so much extra infrastructure to make this work. So
I killed the mojo here. John's like, oh man, all this effort.
Well, I tell you, it was fun to write, and I learned a whole lot about MSAL token caching and exactly how it works, rather than sort of my assumptions. So, because this is a confidential client, we have a secret that represents our application, right, or some type of credential. And in this case, it's just and actually, in this case, it was a certificate. But this is also something that we could look at doing with MSI. But we won't worry about it. We won't broach MSI today. We won't broach MSI today. But so because of this, our timer function would need to go back to Azure AD to get a new access token with that refresh token. And on the surface, that sounds fairly straightforward. But at the time, there was no way to properly derive a caching key to know, okay, which row in the database should I go and look for, right? Because in a web app, a user is signed in, and they, if you're using Node or .NET or whatever, a user's signed in, and there's a cookie, and so you know who the user is because whatever the identity component is of your app has signed a user in.
Yep.
So you know who the user is because they're sitting there in front of you and they're using your app. And it makes it pretty straightforward to say, okay, well, what's my user object or what's my user ID? Because we know what that is. In .NET, it's stored in the claims collection, and that claims collection gets persisted into a cookie. In like Node with Express, we've got Passport that lets you go back and get user claims after they've signed in. So all the different sort of baseline authentication systems that we have available will handle signing a user in and capturing tokens or capturing claims so that you can go back and use them later. But in our case, a user signed in and then went away.
Yep.
They weren't sitting in front of the app. So every few seconds or every few minutes, we wanted our app to go get a new access token and query the graph, right? But without a user sitting in front of us. Because there's no user sitting in front of us, it made it extremely difficult to determine which cache do I use, right?
Yes, it's a per user cache challenge.
That's right. And in confidential clients, like web apps, we need a per user cache. So on a device, it's easy because by definition, this is a per user cache, right? If I have a cache, a file in my Outlook app on my phone, that is a per user cache. If I have a file sitting in protected storage in Windows, for example, in my user profile, that's protected storage because it's ACL'd to me and everything else. So even if I have 20 users who are using a Windows box, my profile data is still specific to me.
Yep.
So if we're saving that MSAL data off into if we're saving that MSAL cache into a file in the user's profile, then it's specific to that user. And we know who the user is by virtue of the fact that we only really have one caching file because there's only one user in this profile.
Yep.
On the web, we don't have that luxury, right? Because you could have dozens, hundreds, thousands of people using a single web server, right? And so that's why the individual session, which is sort of dictated by the cookie that sits on a user's box when they're interacting with your app, that individual user session is what we use to derive what the cache key is, right? Like, how are we going to go and fetch this data out of the cache?
Yep.
And so that's primarily what's happening here. There's a whole lot of sort of flipping through jumping through hoops to make this happen. But we did learn a lot about the token cache. So the first thing though we need to look at is first we have to sign a user in. And in a function that doesn't have any sort of authentication or anything like that turned on, how do we do that? So MSAL has a really nice method called getAuthorizationRequestURL. And the getAuthorizationRequestURL essentially gives you the URL that you, as the user, need to be redirected to based on some parameters. So right now it's just scopes.
Yeah, because functions don't have a UI to create. I mean, you could set up a static website in front of that, but
that's right.
We can do it dynamically by using the MSAL library.
Right. So the MSAL library will handle generating an authorization request. So this is what's going to take you over to Azure AD. So the actual output of this is something like this. login.microsoftonline.com / your tenant or common OAuth 2 v2.0 authorize, right? So that's our typical endpoint, but then it will also handle putting in things like the client ID, right? So you got your client ID.
Nice.
It'll handle things like your scopes.
Yep.
Scopes. And this with extra query parameters here gives us a little bit more control to say, oh, I also want a form post, right? So this will be, well, this will be something like, response mode form post. Now, what you don't see is everything else, like the nonce, like the response type. All that's done by MSAL, right? So you don't have to.
Nice.
So you don't have to. It is sort of. This is probably closer to a cooking show, right? But although I'll say that I spent 2 or 3 nights trying to figure out what to do here, and it's so incredibly frustrating that I think watching it would be even worse to watch someone try to do this live. So we end up with a oops.
With a URL that takes you to a page
Yep,
where you can actually authenticate as a user.
that's right. So the output of this is just a redirect where we redirect you over to the authorization URL, where you're going to sign in, and the big thing is the reply URL comes back to this auth end method here, right?
So in your app registration in Azure AD, you define the response URL or the redirect URI to be the other function they have here, correct?
That's right. So the reply URL is the function URL /auth/end, right?
Mm-hmm.
And so all this is really doing is just returning back the scopes. And so here we're going to acquire our token by authorization code using the code that was the code that came back in the response. Because it was an authorization code call, we send this over to Azure AD. Azure AD signs the user in, and then sends the user back to our endpoint with an authorization code. The authorization code, of course, we can't use it more than once. We use it, it's only valid for a couple minutes anyway. We use that to swap that out with an actual access token, which acquire token by authorization code does. And like we talked about last week, acquire token by authorization code handles really just persists the token into a cache, be it in a memory cache, be it some other kind of a cache. It persists it into a cache. It doesn't actually do anything with it at that point, right? Then you go back and get the cache a little bit later on.
Right.
So we're going to skip most of this other stuff because most of this is other things that we'll come back around to a little bit later on. But at least for the moment, now we've gotten our token from our authorization code.
Yep.
And the big thing here is in the MSAL token cache. We should get this open up over here. Is we have a per user table token cache assessor, right? This this is the thing that's doing the before access and the after access that we talk about with MSAL.
Mm-hmm.
So in MSAL, the only thing that we do, again, is we do a before access, we do an after access. And the before access is before MSAL is attempting to access the token. So this is our opportunity to take that, to go fetch the data from our persistence provider, get the bytes, which we're doing here. So we're going and fetching this from Azure Table Storage. And then we're doing a deserialize and handling it back to MSAL. So MSAL handles everything with that, right? So MSAL is dealing with the rest of the work to get a token cache out of there, right?
Yeah.
The hard part here is determining this user cache key, and that's what we'll circle around to here in a minute. Once MSAL has a cache and it starts writing tokens to it, then it has to go and persist it, right? And so that's what the after access is. So after MSAL has connected to, or after MSAL has written a token to a cache, now it's saying, okay, I'm done with the cache. We need to go and persist it because something has changed. So that's what this state change thing here is. That's what the state change bool is. It's here in the arguments, and if it has, we're going to go persist it back into table storage, and this is where we're taking the bytes that we're given, and we're asking MSAL to serialize it for us, converting it to a base 64 string, and then saving it in table storage. Right?
Right. Perfect.
So now we have a cache that we can use subsequently for storing a user's refresh token, and then going and accessing that after the fact, after the user is gone, by their name, to go and talk to the graph to get their presence data. So it is the top of the hour. Let's take a couple minutes. And we will come back and take a look at how we're talking to the graph.
Brilliant.
Cool. Be back in 5 minutes.
Stay tuned, everyone. 5 minutes.
Okay. Okay, we're back. So let's go take a look. Let's go take a look back at our function when it comes time to go and actually get the user's presence from the graph, right?
Yes.
So this is how sort of typical of how you'd expect to go and talk to the graph, right? So we got to go get our account, and we have this identifier. And the identifier in this case is where some of the extra work came in, if you want to call it that, to determine what this identifier is. Because if MSAL doesn't know how to address a cache, doesn't know how to go and fetch a cache, then it
Yep.
can't go and get the correct one. So then things like acquire token silent are just going to not work, right? And acquire token silent, typically the way we would use this in a normal web app is we would try to acquire one silently, and if we couldn't for one reason or the other, user
Present the UI.
we'd have to present the UI, which is this MSAL UI required exception. And so back in our other code, in our Blazor app, in fact, I think we had some code specifically for that. To go and fetch some data. Oh no, we didn't, because that's right. In Blazor, we had to do it a little bit differently. Because in Blazor, we don't really have the luxury of redirecting a user, because the user never really redirects at all in Blazor.
Yep.
Because it's all done over WebSocket. So in a typical web app, we would catch this UI required exception, and then we would fling the user back out to Azure AD to go and re-authenticate, because for some reason they need to re-authenticate. The problem is, without an identifier to know which cache to go and pull, we get this all the time. And because this is kind of like a Microsoft Flow, right, or IFTTT, where we're doing this without a user present. If we need a user, there's really nothing for us to do, because we can't. The user's not in front of us. So we could do something like send an email, or we could come back and have the user re-authenticate, but for now we're just logging it. So once we've done that, then we have an access token, and we use the access token to go and request their presence. And this uses the Graph SDK, which I know you're quite partial to.
I love it. Love me some SDKs.
So we've configured our Graph Service Client to use what's called the delegate authentication provider, which really just sort of hands you in the HTTP call before it gets sent, and gives you an opportunity to go and manipulate the headers. So here, this is where we add our access token to our authentication header value, which just adds our access token to our HTTP request. Nothing too crazy there. And then we go and fetch the user's presence.
Why are you synchronizing the call rather than using async there? Oh, you have an await. Oh, you have get async, configure await. Okay, gotcha. Yeah, you're not synchronizing. I need more coffee.
So this goes and gets the user's presence, and if the user's presence has changed, actually this just goes and stuffs it into table storage. So we're using table both for the cache and then also for the history of a user's presence. Right?
So this function actually has an output binding to table storage, so it automatically stuffs it in there.
It does. So instead of having to do all the work of wiring up a new table service client and connecting to storage on our own, instead...
That's the beauty of Azure Functions, right? Having inbound and outbound triggers and bindings, which means that you can have multiple input points and then an outgoing kind of a binding that can be Cosmos, it can be table, it can be lots of different things.
Yep, that's right. And so in our check and update presence, method here, we have our tables, which have our user list, and then also has the last presence table, and then also has our service bus binder, which for functions is a way for us to push and pull data into and out of our service bus, right? So, and all that's configured here, which is nice, because instead of having to have a bunch of extra code specific to creating these table clients, or creating a client and creating a table client from that, instead it's just an attribute on the method signature for a specific parameter. So we're saying, give me a cloud table called subscriber table, and use the use a table name that comes out of the configuration, and use a connection string that comes out of a connection. And now we have all of our connections to tables, and we have our connections to service bus for outputting the presence request when it comes out, right? So one of the big problems that we had, a big problem that I encountered with doing this, was figuring out how to derive the cache key based on some sort of external piece of data, right?
Yep.
So in the after access and the before access, which is when we manipulate the token cache itself, if we look at what's in here in the arguments, right?
Mm-hmm.
We have, let me get my magnifier out here. If we look at what's available in the arguments, we have something like an account, right? So get this over here a little bit. So we have, oops.
Oh, magnifier has broke the focus.
It looks like it.
There you go.
So we have things like account,
Mm-hmm.
right? But we have no account because we have no cache. We don't know which cache. So it's very much chicken and egg. So I can't go and get the account because I don't have a configured cache yet. And if you look at the other arguments that are available, all we have are things like the token cache itself, right?
Right.
Which is cool, except we don't have a token cache yet because we haven't gone to fetch it. So, and that's in after access. I'll come up a little bit here to before access, and you'll notice the argument types are the same. And so I don't have a token cache because I haven't fetched it yet. I don't have an account because I can't go get the cache to go and do it yet.
So chicken and egg problem. How do we solve this, my friend?
So what I ended up creating, I got to get magnifier closed here so I can get back to, looks like my mouse is in a different place than my mouse is in a different place. I can't seem to get rid of the magnifier.
I think it's Windows minus. I think.
There we go. Back to normal.
Did that work?
It did work.
Wow.
So this class is called the per user table token cache assessor, right? And there's a cache assessor. So the biggest change here is that we've got this. I've got this. There's a private variable in this class called user cache key, and that user cache identifier, that user cache key, gets set in this configure call, right?
Right.
So every time I need to do something with MSAL, we have to configure this cache assessor. So let's go look at our. In order to use that, we have this MSAL cache.
Factory.
An MSAL client factory, right? So our MSAL client factory is what's actually going to handle creating new
Per user
MSAL objects for
identifiers.
us.
Okay. Oh,
and
for MSAL. Okay.
Yep. And we'll take a look at one right here. So there's this one here for create for identifier, and the identifier gets passed in as a string. So I can send the string in whenever we need one by calling this create for identifier. And it's going to create a confidential client application the same way we would normally in MSAL. But the key here is that the token cache assessor, that configure call that we have here, this configure that sets the user cache key, it happens here.
Right.
So we're doing the configuration to say, hey, set that private variable to be this identifier. And then we're adding a per user token cache. Right?
But you're calling this one the create for identifier from somewhere else. So what sets that identifier for us?
So the identifier gets set when we use it. So by calling this factory,
we'll
go. So here's our get presence from graph, right?
And you're still passing the identifier there. So there must be another call that sets the identifier somewhere, right?
So the identifier comes out of the table store. But
the first time that you call it, you don't have something in the table store. How do you set it?
So the very, very first time, so imagine we have completely blank tables, we have completely clear, we have no
Yes.
data about what users we have. The first thing
Yep.
we're doing is up in our function itself, we're calling auth start,
Mm-hmm.
which has no sort of state data. So nothing state, there's no real state here because it's just creating a redirect URI and then sending the user down a redirect.
Yep.
In authentication end, this is where we are setting, this is where we actually start to persist some data. So
Right.
we go and get the code off of the request, and we use that to acquire a token with an authorization code. But you'll notice
Mm-hmm.
this create with transient identity here is first,
Yep.
right? So what I learned was if you do any operation on an MSAL cache or in an MSAL object,
Okay.
if you do any operation like acquire token by authorization code, for example, a cache gets created and it's sitting in memory, right?
Ah.
Which means there's no way for me to go and pull it later to go and persist it somewhere, right?
Yeah.
So I end up in a position where I've got this. I have an MSAL object that has an in-memory token cache sitting there with the tokens that I need and no mechanism for doing
Access
anything
them.
with it, right? Well, I can access them for the duration of the request, because of course then the object is trashed and I can't get back
Yep.
to it.
Yep.
So what I end up having to do is create one with a transient identity because again, I don't know the user yet.
Mm-hmm.
All I know is that I've gotten a request with what looks like an authorization code hanging off of it,
Yep.
and we want to ask MSAL to go and get a token for us, but I don't have an
Right.
account by then. I don't know the user. I don't know the account because if you're familiar with OAuth, when you do an authorization code request, the only thing you get back is the code. So the
Yep.
URL is your redirect URL with one query string parameter called code.
Code.
Unless you're Apple, because Apple sends a bunch of extra data back in theirs, which is kind of strange because it makes it difficult to pull it out. But the vast majority of implementations send back just a code. They don't send back any extra data because the whole point is that we have this authorization code so that no user data or token data touches the browser.
Yep.
The authorization code is sent via the browser, and then the server does a back channel to talk to Azure AD to go get the token. And that way there's no token data in the browser, there's really nothing in the browser except for this authorization code, which can only be used the one time. So by the time we've gotten to line 58 and we've done the acquire token by authorization code, by function of going through this operation, an in-memory cache has been created by
Right.
default. So we have to create it with this transient identity first, which the transient identity for me is just a new GUID. It's just a GUID, right? Just some random GUID. So we go and get once we've done that, by configuring our MSAL object in the factory with a transient identity, which you'll notice there's nothing really special about this here, we get a new confidential client application builder. We've configured our token cache assessor with a transient ID, and then we've added a per user token cache, right?
Right.
And the token cache itself is this assessor, and the assessor is our per user table token cache
Sweet.
assessor.
Nice.
And because we've set this variable up here for each individual instance of the token cache assessor, because we've set this here, it means that when we go to do a retrieval, we've got the user cache key right here to go and fetch the user's cache, right? So once we've done that, we can now go and get the account. And when we get an account, it's the account that was used to sign in. So we can get something like a home account ID and get the identifier off of that. And so the last thing that we need to do is toggle that over. So that's what switch transient key to actual means. And really all it's doing is taking that original key, this generated key, and just swapping the row keys over. Right. So if we look over here and we go into update our cache key, when we look in our cache assessor at update cache key, all the cache keys really doing is swapping the row keys, right?
Right.
So now we're deleting our old one once we know we've gotten a successful insert. We're going to delete it.
Mm-hmm.
After we've gotten our successful insert, then we're going to delete it so that we don't have our old transient one here. So it's kind of inefficient in that it is reading a cache, writing a net new one, and deleting the old one in terms of the table records. But this is sort of the most reliable way I found to consistently get a cache the right way.
Right.
So the other thing that happens is we create this what we call a user presence request.
Yep.
And this is just like an arbitrary table that has the row key and object ID of the user.
Mm-hmm.
And this is what we use in our timer job to go say, okay, who are all of the accounts that want a presence update, right?
Yep.
So in a way, it's sort of multi-tenanted in that anyone could come and sign up for this app and start getting subscriptions to their own presence, right?
Yeah.
So we're storing all of this in table. So we just have the partition key in this case is just a user account because I didn't have enough users, at least up front, that I really needed to worry about repartitioning this. And I'm pulling the whole partition for every timer job anyway to go and query through all the users.
Now imagine if everyone at Microsoft came and signed up for your app. That would be, 250,000 people in your table storage?
Yeah, then I'd have to come up with a new partition key for my table. But for me and the dozen other people who were using this at the time, this was more than enough, right? So we're creating a new object and letting functions handle, or no, actually we're doing it ourselves. We're not using a binding here. So we're inserting this object into the user account partition. And then we try to send the user to hey, thanks for signing up. We'll start doing your stuff. We'll start polling your endpoint. We'll start polling for your presence and pushing it to your endpoint soon. So this handles creating the token cache, persisting it into storage, and then creating a record that user exists so that in the timer later on, the timer job itself, or that's what this subscriber table is.
Right.
So it's this user presence request. The only real query here is that the partition key equals user account. And then for each one of these users, we're going and doing a get presence from the graph.
Right.
And get presence from the graph. This is where we're doing our MSAL factory again, this create for identifier. Because we have an identifier that's stored in database or stored in tables. So now we can create from our MSAL factory an individual identifier or an individual MSAL client just for that specific identifier.
Per user, in other words.
Correct. Per user. We can go and get that account and then go get a token. So that's when we call acquire token silent, and then those tokens that come through are specific for that user. So we can go and make the call to get that user's presence specifically here. And then at that point we're done. So it only took 5 extra files and a constant stream of objects being created and torn down in order to do that. Now, I had put in an issue about this specifically because it was a lot of work, and our guidance in our docs explicitly says if you're using a confidential client application, you need to make sure that you're using a per user token cache, right? And I struggled to figure out the best way to do it because you could also just use a static key. You could just use a key. It's a string. It doesn't matter what it is. But the problem with that is now you end up with one large cache that has everybody's tokens in it. And that's not obviously not something you want to do. You don't want to commingle tokens from different users, right? In the same cache. Not to mention the caches would eventually get large. If you had more than a few dozen people showing up, you may end up in a position where the caches themselves are so large that they don't fit. You've got these enormous caches that you're trying to load in memory. And so when you're doing confidential client applications, you really do want to focus on how do I create MSAL objects per user. And I think the other big thing I sort of learned about this is that we have these objects called confidential client applications, right?
Yep.
So we're creating this thing called a confidential client application, but using this confidential client application builder. But in reality, it's not really a confidential client application, right? It's a confidential client application token cache. that's the level of specificity of these objects, right? So the individual confidential client application objects that you get from MSAL, they really have to be unique at the token cache level, not at the individual application level.
Gotcha.
Because originally I started thinking like, oh, I'll just create a singleton and inject it in startup and swap the caches out on demand. But the more time I spent doing that, the more I realized that it wasn't going to be feasible because the application object in MSAL is too broad. It's not specific enough to be usable when we need a per user token cache. And so that was the net of all this. That was the net of all this sort of all this code that ended up having to be built to make this happen. But it's all out there, and as I understand it, this is no longer an issue. So the issue that was closed this morning was that the identifiers are now sort of derived correctly. I'm not entirely certain how. Not entirely certain how that would work unless there's extra data that's being pushed into the arguments. Because originally, you would think if you had an argument for before access, right? If you had an arg like not account, because account is sort of a heavy object, but something like login hint, right? Because you can login hint's just a string. If you could send in a login hint and get it as part of the args, then you could swap caches out on a single object, right?
Yes.
So if you have one confidential client, if you've got a login hint, you can use multiple cache files with that single object and pull back whichever one you needed at runtime, which would be great because then you wouldn't have to go through the trouble of creating new objects every single time.
Yes.
So we need to go and look and see what that looks like for maybe sometime in the next couple of weeks because it's not out in the NuGet packages yet. But I think it's for these types of applications. We're seeing customers build all sorts of things that have all kinds of different mechanisms for how they work together, and I think this is only going to become yet another mechanism for accessing data in the graph, especially as the graph gets more and more robust with all the different services and everything else that it has that it's got floating around in there. So this code is out and available. I wrote a blog post trying to explain some of what we had just explained, but it's out there. It's available. I don't think it's terribly. I think part of it's relevant if you're interested in MSAL and token caches. In that it gives you a lot of sort of insight into how to manipulate the cache and or maybe not manipulate the cache itself, but how do you do things like store a per user table cache or per user token cache, and how do you use different persistence providers like a table storage to go and do it. And of course, now that we have webhooks for presence data, most of this doesn't matter specifically for presence, but there are, of course, tons of other pieces of data that are available in the graph. And if you're doing anything else that doesn't have a webhook yet in graph, this is one option to consider, especially if that's sort of critical or super important data that you want to get webhooks for.
Yeah.
So it's out there. The local function is pretty there's not really a whole lot to it. In fact, I never renamed it from function 1 because it was just pretty minor. So all it's doing is reading from a service bus trigger. I don't know if anybody's used Philips Hue's API before, but calculating light colors is super confusing. It took me a long time to figure out which light colors I wanted to use for different ones. But this is it, right? All it's doing is getting that there's new data off of the service bus queue, and then dumping that in an HTTP call to the API, to the local Hue hub, right?
That's insane. Why did they not choose like proper RBG or HTML codes for their colors. It's another proprietary thing they have to deal with, right?
Well, I don't know if it's necessarily proprietary, but it's a calculation of all the different colors. Plus, I think the luminance is mixed in there somewhere. I don't know.
It's like an adding all the values into one and then coming up with that. It almost feels like that, right?
Well, I ended up in a place. Well, no, it's like it's 0 to 65,000 or so. I ended up
Oh,
I ended up spiraling really deep on like uh, uh, color color Twitter and color Stack Overflow, where people were having arguments about RGB versus sRGB and true color mapping and monitors and all this stuff. And I was like, okay, this is
oh,
this is
like proper audio files where they will argue for hours about sound and headsets and what have you. I didn't know there was such a thing for colors, but there you go. There's a whole new spectrum of interest that I didn't know.
yeah. I mean, they're professionals. They're very particular about colors and about what's the word um, in
That
expressing specifically the color they would like and reproducing exactly the colors they would like. And there's just I was surprised at the volume of discussion and yet the lack of available answers because
right. Everyone has an opinion, but nobody has the solution. I like it.
well, I mean, in fairness, that's what we're doing every week, right?
Yeah, well, would you provide some kind of an answer or implementation? Whether it's right or wrong, I don't know, but at least we are trying to show people how to do certain things.
No, that's true.
Uh,
That's true.
as for colors, I only know the basic ones, so that's why my wife banned me from teaching my kids colors because I would call something pink, and my wife would be, no, no, that's purple. It's like it's different version of pink in my eyes.
Well,
Yeah.
anyway, so I think next week we're gonna do our first sort of podcast slash informational session, right?
Indeed, there will be no coding. I mean, there might be some discussion about code, but we'll try to make it more audio friendly rather than visual friendly. And we are trying to line up our first guest. So stay tuned. It will be a shorter segment, and we want to make sure that we cover subjects that you would like to hear. So let us know if you have a specific kind of a desire or a host that you would like to see or a guest that you would like to see on our show.
Very cool, and that'll be next Tuesday, the 28th. This Thursday, we've got our community hours at 11 a.m. Eastern, 8 a.m. Pacific. So be sure to send us your questions on Twitter or on Twitch or wherever, however you can get a hold of us. Our Twitter names are underneath our faces, so feel free to reach out, send us your questions. I think we're going to take a look at some community code on Thursday, too.
Yes.
Now that we're sort of back from vacation and full strength again, at least for a little while.
Yeah, for a little while. We'll see. We need some time off as well at some point, right?
Yeah, so I'm going to try to take my kids to the beach and stay as far away from people as possible in a couple weeks. I'm not quite sure how it's going to work because
Yeah, I was going to say good luck with that because
Well-
given the current situation, and I mean the weather is so nice over here that everybody's trying to be outdoors and stuff. So it's hard to avoid people, especially when the weather's nice.
yeah. Well, and I live in South Carolina too, so
Yeah, you got your own challenges there.
yeah, where nobody wears a mask. Most people shout at other people about wearing masks, so it's kind of a mess here. But we you work with what you got.
Exactly. Yeah, you can't change the world around you. So worry about the things that you can control, my friend.
Yep. So I think we're kind of wrapping up a little bit early today. I know we've got some stuff we have to do here in the next 15, 20 minutes. So we're going to wrap it up a little bit early today. I hope you enjoyed
Yeah.
it. And we will be back on Thursday, 11 a.m., taking a look at some community code and letting you know about any news, views, and new happenings that are going on.
Absolutely.
All right.
Thanks everyone for joining us. Have a lovely day.
See you then.